In this section, we will talk about transformations. Before we talk about transformations, let's talk about parent functions. Parent functions are functions that get transformed with a horizontal, vertical shift, or a stretch. So our first parent function we're going to look at is f of x equals to x squared. So we have our inputs as -2, -1, 0, 1, and 2. We're going to plug them into the function to get the outputs, and then we're going to graph it. So if x equals -2, then we want to find out what is f of -2. So remember, we always take the input, replace it with the x. So -2 squared is 4. So our first point is -2, 4. Our second point, we're plugging in x equals -1. That's our input, so we replace the x value with -1. -1 squared is +1. So our next point is -1, 1. If x is 0, we want to find what is f of 0. This is 0 squared, which is 0. So our next point is 0, 0, 0. If our input is 1, this is 1 squared, which is 1. And if our input is 2, then this is 2 squared, which is 4. So we have -2, 4. We have -1, 1. We have 0, 0, 1, 1, and 2, 4. So the graph of f of x equals to x squared looks like this. Okay, let's go to our next parent function, and notice that the graph is symmetric with respect to the with respect to the y-axis, which means that this is an even function. An even function is a function which is symmetric to the y-axis, as we talked about in a previous section. Okay, let's sorry, this should say graph f of x equals to the absolute value of x by completing the table below. Next, our next parent function is the absolute value function. So we're going to get f of -2. Once again, this is our input, so we're going to replace the x in the absolute value with -2, and the absolute value of -2 is 2. So we got -2, 2. Just a quick refresher, the absolute value of x, this is the distance from 0 to x. So for example, if we have the absolute value of -2, then the distance between 0 and -2, this is 2 units. So because absolute value represents distance, it's always going to be positive. So the absolute value of -2 is +2. We got f of -1, which is the absolute value of -1, that's 1. In other words, the distance between 0 and -1, this distance is going to be 1. So our next point becomes -1, 1. F of 0, this is the absolute value of 0, which is going to be 0. Then we got f of 1. The absolute value of 1 is a distance between 0 and 1, which is just going to be 1. So our next point is 1, 1. Our last point, we want to find out what is f of 2, so that's the absolute value of 2, and that's equal to 2. So the distance from 0 to 2 is going to be 2 units. So we got 2, 2. Now let's go ahead and graph this. We have -2, 2. We have -1, 1. We have 0, 0. We have 1, 1. And we have 2, 2. So our absolute value function looks like a V. It's going to take a V shape. It's going to look something like this. Now notice the difference between the two. They're both symmetric with respect to the y-axis, but our x squared, our quadratic function, takes a U shape, whereas the absolute value function takes a V shape. Next one is the square root of x, and once again, this should say square root of x. So here, I'm not going to pick -2, -1, 0, 1, and 2 because I want to pick numbers that are going to give me perfect squares. So, and also, remember that if I take the square root of a negative number, that's not a real number. So I can't take that. I can't take -3. I can't take -2, can't even take -1. Remember we talked about square roots and their domains before, that whatever this expression is inside the square root, that has to be greater than or equal to 0. So my first value of x I can choose is going to be 0. And then I can pick any number that's greater than or equal to 0, because square root of 1, that's a real number. Radical 2, that's a real number. Radical 3, that's a real number. So I can pick any numbers that are greater than or equal to 0. So I'm going to pick 0, 1, and since my graph is limited to only 6, I'm just going to pick 2, 3, and 4. Those will be my 5 points. So f of 0 is going to be radical 0, which is going to be 0. Okay, f of 1, that's going to be square root of 1, which is 1. And you can put this on a calculator. You'll see that radical 1 is 1. So your next point is going to be the point 1, comma 1. F of 2, that is a square root of 2. If you put that on a calculator, you're going to get 1.4. Okay, so take out a calculator, put in radical 2. It should give you 1.4. And then we got f of 3. Put that on a calculator. Radical 3 is 1.7. And then put in 4, so f of 4 is radical 4. Again, feel free to use a calculator, but that'll give you 2. Okay, these are my 5 points. Now, once again, the reason I don't pick -2, -1, 0, 1, and 2 here is because my the domain for for a square root function, it can't contain any negatives, because a negative square root is not a real number. So I'm only picking numbers that are 0 and greater, like 0, 1, 2, 3, and 4. If we plot these, we have 0, 0, we have 1, 1, and then we have then we have 2. Sorry, this should be a 2. Then we got 2, 1.4. So 1.4 is going to be somewhere between 1 and 2. It's going to be approximately there. I have 3, 1.7. That's a little bit higher. And then finally I have 4, 2, which is going to be like right there. So my square root function is going to curve up and to the right. Okay, so that's a parent graph for my square root function. Now these functions are going to get transformed. So remember the basic shapes of the three functions we talked about. We have the quadratic function x squared, we got the absolute value function, which is a v shape, and then we got the square root function that looks like this. Now horizontal shift occurs when the argument is, this is the x value, is increased or decreased. A vertical shift occurs when the whole function is increased or decreased, and a stretch occurs when the argument, again the x value, is multiplied by a constant. So this is an example of a transformation. So we have the x value is being multiplied by a constant, that is a stretch. The h, when the argument, the x value, is increased or decreased, that creates a horizontal shift. So the horizontal shift is going to be the h. And then the k, that is going to be your vertical shift. Now I'm going to graph these real quick, and I'm going to show you guys what these look like. Okay, so to graph, I'm going to go to Desmos.com. Desmos is a really easy and effective graphing tool. So let's first graph our parent function for the quadratic. We got f of x equals to x squared. Now take a look at what happens when I do x minus 3 squared. So the argument x, it's being subtracted by 3. Look what happened to the function. It went 3 units to the right. That is called a horizontal transformation. Now let's see what happens if I add 2 to it. Then it moved up. So let me actually do it as two separate functions. If I put f of x equals to x minus 3 squared plus 2, then this was the red one's the original function. The x minus 3 squared, it shifted it to the right 3 units. X minus 3 squared plus 2, it moved it up 2 units. Okay, so I'm going to get rid of the middle function. And our transformation was, the horizontal transformation was 3 units to the right, and the vertical transformation was 2 units up. So basically our vertex went from being 0, 0 to 3, 2. Now let's take a look at what happens if I put a stretch. So let's say my stretch is 4. Look at what happened to the function. It shrunk. Compare the original function, the parent function, to the new function. It shrunk. If I increase that to 8, it shrinks even more. If I increase that to 100, it shrinks even more. If I write that as a decimal, like let's say I write that as 0.5, then it gets wider. If I write that as 0.2, it gets even wider. So the thing to know here is that if the stretch is a number greater than 1, like if it's 3 or 4 or 5 or 6, the function gets narrower. If the stretch is between 0 and 1, like 0.1 or 0.2 or 0.3 or 0.4, then the function gets wider. Now what happens if the stretch is negative? Then the function turns upside down. So we're going to take this concept of a horizontal stretch, a horizontal shift, vertical shift, stretch, and we're going to be doing some graphing using this. So let's do one example here, and the rest of them we will work on in class. Okay, so we want to graph this by completing the table. Now here's the most important thing. In a quadratic, a function with a square, the vertex is going to go in the middle. Okay, now here's how you find the vertex. The x value of the vertex is found by setting the argument or the x value equal to 0. So we're going to set x minus 2 equal to 0, which means x equals to 2. So that is my x coordinate. To get the y coordinate of the vertex, I just plug in f of 2. So that's going to give me 2 minus 2 squared minus 3. According to the order of operations, we have to do 2 minus 2 first. 2 minus 2 is 0. 0 squared minus 3, that's 0 minus 3, which is negative 3. So my vertex is going to be 2, negative 3. Okay, look how that relates to the horizontal and vertical shifts. X minus 2, it means that the graph, the vertex goes from being 0, 0, it shifts 2 units to the right. Negative 3 means it shifts 3 units down. So my new vertex is going to be here at 2, negative 3. And then I'm going to pick 2 numbers to the left of 2, 2 numbers to the right of 2. If I plug in 1, I'm going to get 1 minus 2 squared minus 3. 1 minus 2 is negative 1, so that's negative 1 squared minus 3. Negative 1 squared is 1, and 1 minus 3 is negative 2. So my next point is going to be 1, negative 2. If I plug in 0, I'm going to get 0 minus 2 squared minus 3. 0 minus 2 is negative 2. Negative 2 squared is 4. 4 minus 3 is 1. So my next point is going to be 0, 1. On the other side, if I plug in 3, I'm going to get 3 minus 2 squared minus 3. So all I'm doing is I'm replacing x with the input. So 3 minus 2 squared minus 3 minus 2 is 1. So I get 1 squared minus 3. 1 squared is 1. 1 minus 3 is negative 2. So I get 3, negative 2. If I plug in 4, I'm going to get 4 minus 2 squared, replace the x with the 4, minus 3. So it's 2 squared, which is 4. 4 minus 3 is 1. So my next point is 4, 1. If I graph these, I have 0, 1. I have 1, negative 2. I have 2, negative 3. That's my vertex. Let me get rid of this point, the 0, 0. Then I have 3, negative 2, and then I have 4, 1. So my graph is going to look like this. And we have just graphed a transformation. Our transformation was 2 units to the right, 3 units down. The horizontal shift is given by the argument, and the vertical shift is given by the negative 3. So our horizontal shift is 2, vertical shift is negative 3. Our domain is negative infinity, infinity. Our range, our lowest y value is this one, which is negative 3, and then it goes up from there. So our range is going to be negative 3, infinity. Okay, the rest of the problems we will do in class.